We are recording. Good evening, everyone, and welcome back. For those of you who are joining us for the first time, my name is Kyle Masters, and I'm the president of the Penn State Turfgrass Club. And I'll let the other officers introduce themselves as well.
This is McFarland is here.
I'm AJ Weil, and I'm the secretary of the Turf Club.
My name's Ben. I'm the treasurer.
All right. Tonight, we're joined by our special guests, Paul B. Latshaw and Ben Dewan from Marion Golf Club. Paul will be talking tonight about the historic restoration project at Marion in 2018 on the East Course and future employment opportunities for students as well. So Paul, Ben, thank you guys for joining us tonight, and welcome to the Penn State Turfgrass Club.
Well, thank you, Kyle. Thanks for inviting us. And obviously, I'm a Penn Stater. Spent a lot of time up there. Football team's not doing too good this year, but it's been a pretty wacky year. But honored to be doing this. So we'll go through this quickly. Just a little bit about the restoration, the overview. The first component of it was starting with an irrigation basin, creating a 650,000 gallon storage capacity. New pump station to be able to put out 2,250 gallons a minute. Transfer pump station to basically feed the basin. All new irrigation system with rainbow controls and a 2-wire system. Precision air, 18 units were installed with 17 being in the vault with 1 being above ground. Power grid to feed all the precision airs and future fans. We basically put in about 9 miles of 480 cable with this process. Little about the restoration overview. All greens were rebuilt to USGA specifications. It was 3.46 acres and comprised 21 greens. All the approaches were rebuilt, shelled out, and that was 1.3 acres of approaches reconstructed. All the tees were reconstructed, and we also added 15 new tees between forward tees and championship tees. All the bunkers were rebuilt, and we added bunkers, so we have 4.36 acres of bunkers. They're all lined with the Better Billy bunker system. All the fairways were regrassed and recontoured. Drainage, we put in about 20 miles of drainage. A lot of that was related to making sure that every feature like USGA greens, all the bunkers had a positive daylight, and then a lot of seepage drainage installed in different areas. And we put down about 35 acres of rough sod throughout the golf course. As far as the project, I mean, most people have a lot of time to plan these projects. Basically, I was hired back in March of 2017 was my first day on the job. And April, we started really formulating our design team. So we had basically 10 professional designers from like, civil engineers, engineering groups, electrical engineers, irrigation people. And so we had to formulate a whole design team to be able to get this whole thing going. Materials and basically financial management, we're basically formulating this budget as we're going. 6 major bid packages were sent out. So you think about, just sending out a bid package for any project. Usually you send out your specifications, you have a pre-construction meeting, they come back and you vent through that, then you answer those questions. So we did that 6 different times with, golf course construction, irrigation, water supply, pump house, power, and other miscellaneous items related to the project. We selected 8 contractors, so same type of process where you had to go through it, event all your contractors, do your preliminary construction meetings, go through the bid specifications, and that type of thing. That's all going on while the East Course is open. All this stuff was going on at the same time. So we had, Burr Construction doing the irrigation basin, Leibold Irrigation doing the irrigation, Caveman Construction, Golf Course Construction, and then LeBar. And then, permits. Obviously we were going to be working the floodway. We had stream crossings that needed to be done. We need to elevate the 11th green. So we had to do basically permits with the Delaware County Soil Conservation, Pennsylvania DEP, Army Corps of Engineers, the local township, and then the Delaware River Basin. So we were, trying to get all these permits lined up and submitting all these things while or before we could even start. And then we started construction with the first phase in November of that year. So as you can tell, pretty quick on the whole process. With we're usually try to have a few years of work into these things, and we really got this going within less than a year. The construction schedule. November of 17, we started the water storage basin. February, we started putting main lines and power for the PAs and the fans. March of 2018, we started the pump house construction and the equipment associated with that. May of 2018, the golf course construction actually started. And then September was our goal to have the final seeding done on all the greens, and we did not meet that goal on some of the other areas. So let's just start with the basin. This is a picture of what the basin used to be at Marion. Marion's had a long history of really having some water issues, really storage. It's a tight golf course, 120 acres, and really no area for a big body of water. So this was the basin. Basically, what it was 175,000 gallons of water. So it was like a big intake, if you will. A heavy night of irrigation could be up to 400,000 gallons a minute. So you were constantly turning this thing over and trying to recharge the water into this basin. The forms that we were using were city water, basically 2,000 gallons a minute. The line item for the budget for that was about 100,000. We did have a transfer pump station that supplied about 150 gallons a minute, and we had a gravity feed from 13. So really what we had is a situation, we didn't have enough storage area for a night's worth of irrigation, and we're really dependent on city water. So what we came up with, with venting out all the different the engineers, some of these people had some ideas of doing what's called a Geo Storage. And Geo Storage is used a lot for construction sites and stormwater management, where water goes into these basins and then they let them discharge at a desirable rate. Well, we wanted to hold water. So we're very fortunate. We had a member that, is a civil engineer and also an architect that has been involved in all kinds of different projects. And he really helped design this. This is some of the sketchings that he did, but basically we're going to build an underground vault with a pump station on top, so you never saw any of the water, and with the goal of getting 650,000 gallons of water storage, and also try to reduce our dependency on Aqua City water. This is the first phase. This started in, basically the fall of 2017. And, this is pretty nerve-wracking because you knew that we were going to be doing a golf course renovation and we needed water, and this was our water source. What we did is we dug the hole, and then from there we put a liner in. So this is just a picture showing, the 12-inch woven with a 40 mil liner, and then a geotextile on top of it. From there, everything that was done on this was all done with the slinger truck. So this picture here, what led up to this is we put 6 inches of stone on top of the liner, and then we also put 26 truckloads of concrete on top of this, because we're building this basin really in the water table. So the concern was that if we didn't have like the concrete to hold this down, that potentially the liner could come up. So this was actually done on a Saturday. 26 truckloads of concrete went down on this. This is showing what they look like. So basically, I refer to them as gabions, but the real term is the Geo Storage. So you've got these chambers. They're 9 feet high and basically 12.5 feet wide. With the stone in between, you basically have 45% storage with the stone that's in there. So we were able to basically have just not these open areas, but also the stone as storage. This is a picture of once they're created, and once again, the slinger truck putting the stone in. You can see that we had, basically three areas that we had open, but the whole perimeter all the way around this, it was all part of the liner. All that stone actually held water that we could potentially use for the irrigation system. These lids, like I said, they do this in these geo storages. They use them for, commercial developments and that type of thing. They actually build parking lots on top. So the contractor that was doing our work, this was the first thing he did is basically built these lids on site. So we did them in 3 different lifts. That was about 30 truckloads of concrete. And once they were built, we then took them down and started placing them over top of the storage basin. This is actually just a picture of how big it is. So it's 90 feet, 95 feet wide and 170 feet long. It's basically the size of an Olympic swimming pool. And this once again gave us 650,000 gallons of storage. Now, obviously, a lot of other golf courses, have a lot more storage, but for us, this was enough where we could basically do a real heavy night of irrigation and then start recharging it and move away from the dependency of city water. This is basically the soil going back over. About 6,000 cubic yards of soil was put back on this. And you can see from this, you've got the lids, you got geotextile fabric going over top. And you can see in the bottom right that that's actually where the pump station is going to sit. That's the wet well that was created and basically working in this general area. This is a picture of it being finished. So you can see that the pump station in the bottom, but the way this works is we have 2 extraction points from the stream, number 10 and then also number 11. So they gravity feed to 2 basically concrete structures. First one is like a settlement type structure, and then the second one is where we basically pump the water out and into the basin. So the basin can't get filled unless we transfer the water from the streams. And we also kept the city water feed to 2,000 gallons a minute. So if we get in a situation where we got into this a little bit this summer, we were dry, bicarb started building up a little bit in greens, and we know our stream water quality wasn't very good, that we would drain the basin down, use it, then fill it with city water, and then perform a flush on the USGA greens. These are the intake structures. These are 14 feet deep. So you can imagine the invert going across 11 fairway and what that looked like with the installation. The way these work is, we set it with the pump station, and we just want to extract as much water as we possibly can without hindering the flow of water going downstream. So they're basically 2 VFD pumps. We can take as much as 700 gallons a minute. We try to dial in about 350 to 400 gallons, and it all depends on how the stream is flowing for us to put that water into the basin. Then in the pump station, this is actually my 5th pump station that I've done. And we are basically filtering the water before it goes into the basin, and then we filter the water as it exits. So, we've got the typical fertigation, wetting agent, acid injection type deal. But, this whole thing is basically, the one panel, if we see the basin's getting down, it calls for water, it fills it, it filters it before it goes into the basin, and then it basically discharges into the center of the basin. This was a little bit unnerving for the fact that we're behind on the construction of the pump station, and we did not have our pump station or the basin. There's some other things that led up to this that I didn't really talk about. When we did the basin, the specs were for washed stone. Obviously, in the middle of winter, you can't get washed stone. So we started noticing we were filling it, the water's pretty murky, and all that stone dust that was in the basin, we had to basically clean that stone, pump it into a big silt bag, and do that multiple times to get the basin cleaned out. And then we didn't get power. So we actually ran on a booster pump that basically took the city water and went into the golf course. So if we wanted to irrigate, we had to go start this booster pump, this diesel booster pump, and use that for the irrigation system. And we use this, like I said, to July 13th. And we also had 9 greens were being grown in when we're using this booster pump. Irrigation, once again, this was really fast tracked. Paul Roche, we hired him. He's the first consultant I hired, and he absolutely did a phenomenal job of getting this design quickly and getting out the bid and figuring out the vendors and everything else. So, from the time I started and the time that we started the irrigation, it was 10 months. Typical, irrigation system back to back on greens and fairways. Tees are basically gridded. The green compounds were done with a spoke and wheel is what we refer to. Knowing that we were putting all the main line in to make sure we had water in different areas, but knowing that we're blowing up greens, we did an outer loop, a 3-inch outer loop, and put all the taps in so that we could be constructing the green. And when the green got done, the water was in a perimeter that we start putting the lines in around the greens versus trying to go right around the green with the construction. Plus some of the features that we had, the bunkers are very, very close to greens. There's a few situations we actually had to put the pipe in the cavity. There wasn't enough room between the bunker and the green. That happened on number 7 on the right side and a few other isolated areas. We had 5 miles of main line. One of the things that we did, and this was something new, I've done, God, probably over 100 holes of irrigation through my career, but we did PVC main lines and we did HDP laterals. Most people either do PVC main lines and laterals or all HDP. And the thought process is when you usually have leaks, it's usually on your smaller pipe, the gasketed 2-inch pipe. So we did PVC main lines and HDP laterals, and that was about 21 miles that we put in with the HDP laterals. I can tell you that the irrigation system, we can go 3 hours without the PM pump actually cycling. So that's a pretty tight system. I think it's really a combination of, the fittings that were used, the installation by Leibold, and, the design that Paul came up with. We did rainbird irrigation. We put in over 2,100 irrigation heads throughout the golf course. We did 26 miles of maxi wire, and then 9 miles of 480 power that went to just all the PAs, the pump station. We had to feed the pump station a new power source because it got bigger, and a few other items that we needed to put power in for. With this, all the other irrigation systems I always ever done were always satellite buildings. And when I was here superintendent in the 90s, I actually put this system in with these buildings and satellites. So this was actually the very first 2-wire system that I've ever done. And I can tell you, I had some reservations about it, but knowing that we wanted a clean look, that we didn't want to have these buildings on the golf course, it really made a lot of sense. And then from the practicality of doing the renovation, knowing the priority was getting the greens done and tees being last. I mean, if you had to string out all those wires, the heads and the staking, it would have been a nightmare. Where we just basically, finished an area, tapped into the 2-wire system, put on controls and added on. So for restorations and renovations, 2-wire system is really ideal versus trying to figure out where all the wiring is going to go. I mean, we started on number 9 green and number 4 green, and we almost finished the whole 2 through 12 side, but still had a tee on number 9 to construct. So, with sequencing and pushing on greens to hit your seeding date because of the opening, this really worked out well for us. Irrigation and drainage, obviously this was a coordination. Irrigation is not grade sensitive, but the drainage is. So we knew that we were going to be putting in about 20 miles of drainage, that we tried to get the drainage out ahead. Irrigation, so it was constant communication and coordination with LeBar and also Leibold irrigation. At times, we would have over 100 people working on the golf course between all the different contractors. That did not include our staff. So it was a lot of fun, but it was also a lot of coordination. But we were very fortunate. We had great contractors with LeBar, Leibold, Caveman Construction, and all the people associated with this. Gil Hans did the design work, and this is just a rendering of number 9 of what we wanted to try to do. So Gil and I went out before the renovation, sort of looked at greens. He hand sketched where he thought we could recapture some pin positions. And if you look, Gil is really a student of the architecture and studied aerials. Marion's extremely fortunate that we have a very excellent archives and pictures throughout all the different years. And you can see this is what number 9 looked like back in the day. And this is actually what we created. So we tried to go back to not the original design, but we picked an error in making sure that we're expanding these greens and capturing green positions that were lost. So the process on greens, I can tell you, the club was very, very sensitive, the contours and making sure that we really didn't change the greens. I think we all know, anytime you aerify the greens, you're changing the contours a little bit. Sand splash changes the greens a little bit, but this was the first step. So we went and, had the guys strip the sod as thin as possible. And then from there, when we wanted to really recapture the pin positions, we really needed to break down the edges. So the edges around the greens are broken down because we wanted to make sure if we're going to add green positions, we want to make sure they're pinnable. And then Gil, what he would do is, once all the sod was stripped off, we would then, he would take bunker sand and he would basically look at the expansions and where he was going to try to capture these pin positions. And you can see this is number 9. Front left was expanded a lot, and this whole green was probably the biggest one as far as expansion. I think it was 27% larger than of all the greens we did. So we really expanded this and tried to capture pin positions that were lost through the times. And like I said earlier, the contours and, Marion Bean is famous and all the history with all the golf. The club was very concerned about, not altering the greens. So before we even started, we did a scan of the greens. And then once we stripped the sod and did the expansions, we did another scan. And, these scans, they do 200,000 points are captured, and the accuracy is like 2 millimeters. So we would basically had the pre-construction scan and then the construction scan in basically soil that wasn't even constructed to look at the internal contours and make sure what we were gaining made sense and that type of deal. And it was also reviewed by the architectural committee. We would then take this onto a spreadsheet and look at what contours, what we gained, what we potentially lost. Some of the areas, we gained some pin positions. Well, we gained pin positions on almost all the greens, with the exception of 12 and 15. We went back to some of the original designs that were changed before the open by Mr. Fazio. So we actually lost a few pin positions there. But, for the most part, we were looking at these internal contours and making sure they matched up. From there, we started the construction. Typical USGA construction. 5-foot grids were laid out when we were doing this with the scan. I can tell you, the stick work was something with the accuracy is something that took a lot of time. We actually had 3 of our Marion staff members on sticks at all times because you got one section where they're excavating the green, one putting gravel in, and one doing final float. So this took a lot of time, and we did not do variable depth because we did the subsurface, but we did put 13 inches on the fronts of the greens. Drainage was it was tighter than USGA specifications. We ended up doing a 6-inch truck line and 6-inch perimeter drain in 4-inch laterals, but our laterals were 10 feet apart. And you can see in the top or the bottom left of this one, this green cavity was actually pumping a little bit. So we actually did some finger drains in that. And, we wanted to make sure that the drainage was tight because the drainage actually acts as a manifold system for the subsurface aeration. So we actually had an engineer do a peer review on the precision errors. And, we talked about going 8 foot, we talked about 12 and 10. And, the engineer figured that 10-foot centers would work with what we're trying to do. So, 3.6 miles of drainage was put in. A lot of the restoration people see on the top, but a lot of what we did was the plumbing, the underside. Let's face it, water management is 90% of the game, and we wanted to make sure that we could move excess water when we had inclement weather. Gravel layer being put in. This accuracy was down to 1/8 of an inch, and you can see once again the dotting, the guys on the sticks. Putting the gravel in. Greens mix, we put in 8,200 tons of mix. We did basically a designer mix, work with Dr. McNitt on this, 85% sand, 10% profile, and we did 5% soil. Our uniformity coefficient on this was like a 3.4 to 3.8. We really wanted to have a firm mix. The testing protocol was pretty tight. Every 400 tons were tested. So the way this worked was the sand was being tested daily. And then when they added the soil, we would run that up to Penn State and they would look at that. And then from there, they would add the profile and we would test it again. Then once it was shipped on property, we would test it one more time. So it was pretty tight protocols, and it was good that we had Dr. McNitt and we could have people actually drive up there and go through this because, this material is going in pretty quick. So, and we're pretty happy with the mix, but we're, really trying to make sure that uniformity coefficient was on the higher side. The infiltration was anywhere from 14 to 19 inches an hour. Air porosity was 22 to 24, and cap was about 18 to 19. Final strike off. This was extremely labor intensive. They gridded these areas on, if it was a hillside or a slope of some sort, it was 12-inch grids. If it was on a level area, it was 18-inch grids. So this could actually take a day for LeBar and our guys to actually do the final strike off on a green. Extremely labor intensive. Shalene, which was the foreman for our project, and it did this at other courses, told me, he's like, be prepared to go through about 3 cases of paint per green. And I thought he was nuts. And truthfully, we went through that. I mean, because you're putting dots everywhere. And this is really, really intensive with the final strike off. And then from there, before we could seed, we would scan the green again when we were done with the final strike off. So we had the greens from 2017, the pre-construction, and then what we created. And there would always be something, we always reviewed this with the committee, and we'd look at those internal contours between the new and the old green, and then also looked at the areas we were recapturing pin positions and make sure that we could use those pin positions. And every effort was made to really keep the internal contours. The creative freedom that Gil had is really on capturing pin positions on the peripherals. After the green was approved by the committee, we would do the seeding. I'm a blend person. I like to blend seed, and we know that this is, a very old golf course. So we wanted sort of a modeled look, and that's going to take time. But we went with 60% 007, 20% L93 XD, and 20% Piranha. The seeding technique, we refined. We actually got to a point where it was almost like an 8-step process. With this, the moisture within the profile is pretty important. You've got to get it moist enough where you can knobby and put the seed down. But basically, we drop seed, we raked, we knobbied, we cocoa met, we hand rolled, we repeated. Did that multiple times and put our pre-plant down right before the strike off, and then from there we just moved on. This was something that the seed guard fabric covers. I did a few seminars and had a colleague that rebuilt his greens at Wade Hampton and told me about these seed guard covers. And the first 2 greens we did were 4 and 9. And I was sort of skeptical on this. So it was a Saturday night, and we've had rain, but really nothing that washed these greens out. So we put the seed guard down on number 9, and we figured, let's just leave number 4 and not put it down. They're only calling for a 1/4 inch of rain. Well, sure enough, we get a heavy storm, an inch comes through, and we basically got to redo number 4. So from that point forward, we put these strike guards or these seed guards on. How long we kept them on was sort of dependent on what was going on. Probably the longest was maybe 8-9 days. There were sometimes that we'd get germination, it'd be pretty warm, we'd take them off and not put them back on and shoot more subdue. Might be like 6-7 days. So, but these were really instrumental in the grow in preventing washouts in normal circumstances. So part of this also, we rebuilt all the approaches. A lot of times people do approaches and they'll do 4 to 6 inches. I think the big thing is, looking at the physical release curves of the material. And we knew that the 721 that we were using, the release curve, the sweet spot was 8 to 10 inches. So we shelled them out to 10 inches deep. You can see the internal drainage that we put in throughout these approaches. So with this, we put in about 1.2 miles of drainage within the approaches. And that really worked out well. I mean, when we opened up, I think our approaches were probably what people really were marveling at, is how firm they were. We just got to keep up the organic matter dilution, but that was well received. Then the subsurface PAs. We were actually the first person or first course to ever put them completely below ground. So this is actually, the way this worked is Dominic makes the PA units, and Dominic is a $1.2 billion company that does air conditionings and heating and boats and RVs. So they built the air conditioning and the heating unit, and then the vault was built by Delta, and they do water features. So this is one of our first ones being installed. And then, the installation. So we would put down stone, concrete to basically keep it from floating, and then all the different air intakes. And then every PA has a bottom drain in it, so that we weren't relying on a sump pump in case water would ever get into any of these units. And we tried to position these PA units as close to the greens as we could. There's a few that we had to do like 160 feet away. We actually, in some cases, with excess soil from the greens and from the bunkers, we actually created mounding in some scenarios to basically put them in remote areas. But you can see that we had an 8-inch PVC solid line going to the green. On the top right corner, you'll see we put in basically a slide gate so that we had the ability to basically go 4 inches, 6 inches, or 8 inches. So hypothetically, if we didn't want to push as much air to the green, we'd take it down to 4 inch. That'd make the air colder. If we wanted to have a little bit more flow, you go to 8 inches. And knowing that different greens were different sizes. You have a green that might be 3,000 square feet. You have one green that might be 10,000 square feet. Then you got the variable of how far the PAs are away. That gave us almost like a damper, if you will, to try to figure out the flow going into the greens. This is actually inside the vault. You can see the left is the PA controls, and then all the 480 associated with it. And the slide on the right is just the lid taken off with the pressure, and then also the vacuum pumps. This slide doesn't look like much, but being that we were doing a 2-wire system and the PAs were run everywhere else in the United States off of basically a satellite system. So meaning you send a pulse, a 24-volt pulse to the unit. Well, we had to figure out how to turn these things on and off with the irrigation system. I can tell you, Paul Roche and Brett Ramsey or Rainbird spent countless hours figuring out how to do this. And since we've done this, there's other companies now making these controls, but we were really the first person to try to come up there. But some of the functions, you have vacuum and pressure. So basically same as sub air. The only difference with this is we also have the ability to put in cold air into the profile, and that's about 7 to 15 degrees. And we have 3 forms of heat: RC heat, which gives about 30 degrees, and electric heat 1 and electric heat 2. Where the electric heat 1 and 2 come in handy is when you winterize your irrigation system, you lose your RC heat. The RC heat and the RC cooling uses irrigation water for the heating and cooling component of it. So this is, the controls. You can see in the PA top right, it was showing the discharge air is about 58 degrees. At the swag, we put in all the areas, almost like a trap, if you will, what we call swags, a low point from the vault to the green. And you can see that the discharge air was 56 degrees and the ambient temperature was 87. This is just showing some of the stuff with the SPIOs, some of the things we saw with the soil sensors that we have in the ground, some of the curves and the deltas that we were getting with running AC. Once again, the SPO in the summer, you can see that on this scenario, 88 degrees at 4 inches, and this one, the best one was 69. I can tell you, you got to run them for a long time to get those type of results though. Then in the heating mode, you can see that the top right temperature is 123 in the discharge, and at the pipe we were about 128 degrees going in, and the air temperature that day was 47 degrees. The PA units will never go above 130 degrees because that's when you start going above 130 degrees, you potentially have structural issues with your drainage pipe. So 130 is all they'll do. If they go above 130, they shut off. This is just a slide showing some of the different things with the electric heats in a good situation. This is just showing some of the root system with the large putting green versus number 11. The large is we did not do the putting greens. These things are pretty expensive. So just showing the root system on the large putting green versus number 11. And then once again, I got ahead of myself a little bit on this, but the controls. This was something that took us a lot of time to figure out how to do with the 2-wire system and the RC ins and the RC outs. So each one of these functions needed basically IC in to a cube relay that then would transfer the power down to 24 volts to trigger on a function. So you have 7 different functions. You need 7 of these different aspects. So, you know, once again, Brett Ramsey and Paul Roche really were instrumental in coming up with this, and a lot of trial and error, but we got that sort of figured out at this point. One of the things that we did run into with the summer, we had, you know, some pretty intensive storms, and you start doing, you know, irrigation systems and 480 going to these vaults, we started to have some problems with some of these devices being damaged. So working with Rainbird and our electrical engineer, what we ended up doing is we put on a surge arrestor on the 480 as it comes into the vault. We put a surge arrestor on the PA controls to the low voltage ICNs, and we put a surge arrestor on the maxi cable coming in. Because what we found is if we took a lightning strike, the PA panel would be fine. It maybe like one fuse would blow. But we were losing some of these ICNs, and that tree strike, I didn't talk to that properly. That tree strike was on number 16, was probably about 20 to 30 feet away from the 480 line going to the PA vault. So, and that tree, the bark was all over the green and everything else. So that was a pretty hefty strike. So we've since put these in, and I think it's made a big difference on our lightning protection. The other component that really was something we just phased in this year, if you wanted to know the discharge air at any time on the PA unit, you had to physically climb into the vault. Climbing in and out of these things when you got, you know, 17 of them is pretty time consuming. And there's always, you know, certain things that something could go wrong, like the filter gets clogged and it's not functioning properly. So we wanted to know what the air temperature was discharge going into the green. So working once again with Rainbird and everyone else, came up with these readers that we put right in the discharge that goes back, measures milliamps, and then it converts it to the Rainbird platform. So we can see now what the discharge air is, along with what the CFMs, the amount of air going through or leaving the vault at that time. This basically is showing how this is done. It's from the irrigation, but you can see that you've got the unit kicking on and it's showing what the temperature is. You got to convert it at this point, but we're able to do that. So we're able to convert it, and we're also able to see what the CFMs are, which what is beneficial on that is you got 2 dampers on these units. So when you're running vacuum, one unit is basically shutting the damper, the other's opening up. And then when you run pressure, they got to go back and forth. So if you have an issue with one of the dampers not shutting completely, in theory, if you monitor this through time, you could see exactly if one of the dampers aren't working or if you have a potential issue. So just another checks and balances. You can go to the irrigation system and say, hey, you know, we're running AC, it's 100 degrees. What's the discharge air? And go to the irrigation computer and see that versus climbing in all the vaults. Marion's sort of known for its bunkering, the white faces of Marion. And one of the first things we did before we even started the restoration is we went and built a simulated bunker at Wheeler. We had three different types of design with, the revetted edge being stacked versus rolling, the fescue versus chunking. We also put in three different types of liner in this test bunker, the better billy bunker, capillary concrete, and a rubber material that I'm drawing a blank on what that was. Didn't work out well for us though. And then we had three different types of sands. The Newport, which was on the right, the Valley Forge Buff, and then the Valley Forge Firm on the left. And that's where we sort of made our decision on, what type of design we're going to do with the bunkers, or, what everyone settled on, the sand that we're going to use along with the liner that was going to be used. Bunker shaping. One of the things that's really good working with Gil Hance and Jim Wagner. The way this works is Gil has his own company, Caveman Construction. They come in, they shape everything. And then from there, LeBar did all the plumbing and all the finish work. So there is really no interpretation, where a lot of times where you have an architect and then you have a contractor, and the architect's trying to explain to the contractor what he wants. And there's a lot of times there's a lot of back and forth, and sometimes things don't turn out the way they want. We absolutely had no change orders on this whole project because these guys were building what they wanted to build in the design. So you can see, this is Jim Wagner. Jim Wagner is one of the most talented shapers I've ever been around. Unbelievable person. And we were fortunate, he was on property quite a bit and shaped a lot of our bunkers. But this is Jim, basically breaking down the edges on side of this green and shaping the bunkers. So typical with any type of bunker construction, we put in about 3.3 miles of drainage. I can tell you, with us breaking down the edges around greens, the concern was we wanted to make sure the bunkers were deep. So that meant if we took 2 feet off of a side of next to a green, the bunker probably went down 3 to 4 feet. So our bunkers are pretty daggone deep. So some of the inverts and getting drainage to go to a positive area. We had some areas we were going through hillsides, 10, 12 feet deep to make this work. So large component on the drainage side, but typical bunker construction with drainage. And then we did do the better billy bunker. LeBar did all the spraying and did all the finish work. And, with that, it was like 2,000 tons of gravel went into the bunkers in the spraying process. So rebuilt all the bunkers, and we also added bunkers. So we added 26,000 square feet of bunkers. There were some bunkers that were taken out at different eras or different periods of the golf course. A lot of those were put back in. Some bunkers were relocated to different areas. Most were moved closer into strategic areas. But so we added basically 26,000 square feet more of bunkers. An idea of what the bunkers looked like before. This is number 13. It was really 60% sand and 40% of this fescue edge all the way around the greens. And what we went to is really 90% sand and 10% grass with a revetted edge. So, going back to what they looked like back in the day, and really going back to the white faces of Marion, where we have that, the sand all the way up, which represents some problems on maintenance, but they're aesthetically, they're very pleasing. Another big component was really the drainage, and not so much just seepage drainage, but also once again going into the main lines and making sure that everything had a positive outfall. We wanted no pits with gravel going, that type of deal. So every green, every bunker, every tee has an outfall to a positive source where it's released. The common theme on this was, we wanted to make sure that we were trying to have good infrastructure and put as much drainage in the ground to really have, firm playing conditions. This is just a good example of a little bit of the drainage. You got a header pipe going up the center, which was 4-inch. We also did a lot of the ADS seepage pipe, the Vantage pipe. So, we tied that in, and then you can see that the bunker on the right, that ties into the main line going down, the green to the left, that goes all the way down the left side. So, some of these runs are pretty long, but we're pretty fortunate that we have, water throughout the golf course. And the runs were bad, but they weren't terrible. This aspect's probably where we got behind on the most, was really the seepage drainage. You can see that this fairway was rounded up, and we really were behind on putting in the amount of drainage that we had. So this was sort of a group effort where, Marion staff was putting in drainage, and then the bar staff was putting in drainage. And, once again, they put in about 8.9 and we put about 1.7. So, this was a large part of the whole process, was, trying to get the pipe in the ground. This is what the golf course looked like from an aerial. You can see that, dirt everywhere, fairways are dead, greens are being seeded. And with that, we wanted to recontour fairways. So Gil and Jim spent a lot of time looking at photos, and that's sort of a tough thing to figure out, because you're going to have future golf events, but you also have membership play. So, what's the right width for everyday membership play, but then also know you're going to have championships down the future. So, a lot of time was spent on the grass lines. We ended up seeding 2 different directions. This Ferrero seeder was absolutely fantastic. Really good germination with this. We went once again with a blend of seed. We went 007 at 50%, 25% luminary, and 25% barracuda. We did do 2 applications of Roundup, which we got a little bit behind with the construction schedule. We'll get to reasons why we got behind a little bit later here. We also rebuilt all the tees, put in about 1.5 miles of drainage. We added 11 new forward tees, and 4 new membership tees for different lengths. I can tell you the forward tees been really, really well received. It's just good for the game. You got people starting out in the game. You got people getting older in life, and don't hit the ball as far. And that was actually, believe it or not, was something that, internally within the club, there was a debate: do we do this or not do this? And I can tell you it was the right thing to do, and the membership has really embraced it by keeping some of these people that are getting a little bit older, where they can still play the golf course. And with the fairways, we actually brought a lot of fairways back too, to make it good for anyone trying to either enter the game or as they're aging in the game. Sod, we ended up sodding 35 acres of rough. That was 170 truckloads of sod that came. We would do potentially 10 truckloads in a week. So the sod, getting it down and keeping it alive, was always an ongoing process. Material. I can tell you that it was nothing uncommon for 30 truckloads of material to come a day, and it be going all out at the same time. 3,600 tons of sand and gravel, 1,500 truckloads were brought in just for greens. And, we had basically, gravel for the better Billy bunker. You got gravel for the greens, you got gravel for the drainage, then you got 721 for tees, capping of the drainage, and then the approaches, and then the greens mix. It was a full-time job keeping up with that. So Dave's actually here right now on this call. He was in charge of ordering all this stuff, and it doesn't sound like much, but really we're the GC of this whole project. I mean, we coordinated everything, all the materials coming in. And, if you don't have the material here and you're on a tight construction schedule, it can hold the whole thing up. So, and Nate Heller, he's a former Penn State guy also. He spent most of the summer in Wheeler Lot taking deliveries, because these truck drivers come and they got sand. They don't know if it's green sand. They don't know if it's bunker sand. They don't know if it's 721. And you got to keep up so they're not dumping stuff in the wrong area. And then as far as equipment, LeBar, they had 66 workers, and just go through, 15 carts, 14 whacker dumpers, 9 excavators, 3 tractors, sand pros, loaders, dozers, libel, they had, 3 excavators and all kinds of equipment, and Berg, all the stuff they did with the basin. So I guess what I'm saying is there was a lot of equipment. Sometimes these guys would park this stuff all together, and you're looking at several $1 million worth of equipment, to get this done in a timely fashion, and really good contractors. Then, during this grow-in, we knew there was always going to be challenges, and the challenges that you fear the most were rain. And unfortunately, we had the second wettest year in the history of Philadelphia. And that really represented a lot of problems with the construction schedule and washouts. I could go through all the different storms, but take home message, a lot of rain, untimely. And I think we were within like a ½ inch of being the wettest. And I really wanted to win that record because, you don't get prizes for second best. You only get if you win, but we almost broke the record. So second wettest year. And this is what you get. Sod washed out, drain lines washed out, greens washed out. And that gets into some really demoralizing situations with staff and contractors where these guys are working countless hours and you're dealing with, constant stuff like this and having to fix it. Here's another example of washouts. And what's tough about that is, you got, this is on a fairway, you've got seed coming up. And some of the stuff's in the center of the fairway. Well, to fix this, you're going to mess up all your seeding, and it's just washouts are absolutely the worst with golf course construction. If you're seeding everything, if you're sodding, you're going to deal with a little bit, but not to this extent. And once again, just more washouts. And number five approach, I think we seeded that, oh God, probably 3 to 5 times. And finally just started to sod in sections. Because 5, if you don't know the golf course, it's a par 4 that slopes hard right to left on the green. And that was in the worst sequence. When we seeded that thing, it just rainstorm after rainstorm after rainstorm. And really all the fairways we seeded, but we got really far behind. And number 11, we just decided, because that's in a floodplain, we sodded the whole fairway. Because at that point I was tapped out on washouts, and I'm like, we need 30,000 for sod. We're sodding the fairway. We're not dealing with this. And because it was sort of catastrophic in some regards, but we got it done and it turned out well. But, that's a part of construction. Whether it's a lot of fun. I can tell you the project is the most fun I've ever had ever. There's also some pretty difficult times you deal with this type of stuff. And then, stuff like where, drainage and some of the blowouts, you always have situations where, we had some areas where, we're having 100-year storms, and, 4-inch pipe or 6-inch pipe normally does fine. But in the 100-year storm, some of this stuff we had to go back and upsize a few pipes in a few different areas. And you can see, there's a few that happen on fairways. And then one of the projects that was scoped to be done with the closing of Marion was the Ardmore Avenue project. So this is 13T in 2019. We recreated this. We went to, it used to be 1 level T, so we have a 2T system. But we knew that the Ardmore Avenue was going to be doing 2 bridges. One that's next to our golf course and a SEPTA bridge. And we were working with PennDOT, and this has been somewhat of a challenge, but we actually put a safety path in the storm culvert that was put so that we would have 1 less road crossing across Ardmore Avenue, because Ardmore Avenue gets about 10,000 cars a day. So this is the T being blown up, the bridge being constructed, and a little bit of the retaining wall. You can see this is on number 12 side, that you've got that underpass, and you can see the concrete there where, you're going to drive a cart and people are walk underneath the road and come up. And about 1,500 cubic yards of soil is moved on this project. Wall being constructed. So everything you see from the stair steps to the right was all Marion, and everything on the left was PennDOT and Ekman doing the construction on that. Stonework, we actually need to update this. This is pretty much done. But, we built this wall, it's about 14 feet high to retain the tee. And then we used all natural stone, and you can see where the guys are working. That's the concrete safety path where carts can come through and also maintenance can come through. And then, golfers can walk underneath and go up the steps that aren't seen on this. And this is actually not the most recent. We just completed everything to the right of number 12. We regraded the hill. So tying into that cart path is all been sodded and graded, and we're almost done with this. And we in theory we're supposed to be doing this the same time as the construction project. It got delayed a little bit, which we're glad it did, because this turned out to be a little bit more of an undertaking than we thought. But it's going to be a nice addition to have our staff have one less crossing on Ardmore, and members safely walking underneath and not ever worrying about cars flying over the hill and that type of situation. Okay, questions, and obviously we're looking for interns. I think we run a really good intern program. Kyle has been through the program. I think one of the things, obviously I'm gonna do a little sales job here, but one of the things that we do, I think, is different than a lot of other clubs. We have the general manager runs a program where, not just the interns on grounds, but the interns in the pro shop and culinary all get together. All the department heads will talk about their career to all the different interns. We go through like finances of the club. How do you become a Marion member? What to look for on statements and financial statements of a club. Like if you're looking at a job, how do you determine if the club really has good financial stability, or those type of things. And so we try to do 3 or 4 of those a year. And I can honestly say this year with COVID, it was scaled back just because of social distancing. But we have a pretty good program. We're always looking for good people. If you got attitude and effort, we'll fill in the rest of the blanks. And one other thing, just everyone involved in this project, Gil Hans, Jim Wagner, Leibel, Labar, Shalane, that was a project manager on this, Paul Rosh, Rainbird people, staff, in the membership. All this all happens with, teamwork and dedication, and we're pretty proud of what we got. So any questions anyone has?
I'll just add on to your intern plug. Just to say I was able to be a part of this restoration project and worked there for 8 months, and it was an awesome experience, and it was a once in a lifetime opportunity that I got to be a part of. And Marion's a big part of Penn State history, turfgrass history, and it's a very, very great program. I couldn't say more about this program, and I agree. Like Paul said, I attached in the chat, there should be a URL to the internship program on the Marion Golf Club website, and also Paul's information, email address, and contact cell phone number is also in the chat. If anybody has any last minute questions, please feel free to reach out.
Hey, this is Andy McNitt. Would like to know how things are going a year later, and what are you doing to keep the organic matter down? You want to share with the students a little bit about the process that you go through in a year to manage organic matter and those greens and approaches?
Yeah, so obviously, we built up a little bit organic this summer. So this fall, we went in with 5/8 inch tines, picked up the plugs, worked sand in, did sand and jet grade in one direction and 1 millimeter the next. We did do a light aerification in August, and the goal, or what we're going to do in the spring, we'll look at our physical analysis, but we're thinking another core aerification and maybe 1 millimeter grade in 2 directions on those. And approaches, we basically did core aerification, and then also the grade going through them. So, and I think really just try to get, the top dressing, which is a little bit of a challenge because you try to top dress with what you built the greens out of, and some of that 18 mesh stuff doesn't work in too well, obviously. So, but we'll benchmark and see where we're at, and go from there.
I appreciate, as an impressive presentation there, Paul. Appreciate you taking the time.
Well, I appreciate your help. I mean, you guys jumped through a lot of hoops to look at those test results to make sure we could keep going. I don't know how many times drove up there at wee hours in the morning and got them turned around the next day.
Well, you left no rock unturned, that's for sure. So,
Hey, Paul, John Kaminsky here. You guys had the open in 13. Is there any talk of future events at Marion after the renovation?
Yeah, well, we've got 22 the Curtis Cup, 26 the amateur, and there's dialogue. Nothing firm, but there's dialogue, and it's positive.
Good, excellent presentation. I learned a crap ton, so thanks.
Well, thank you. Well, guys, if there's no other questions, and Penn State, guys going to school there, be Penn State proud. Damn good school. A lot of my career, my success is related to going to school there. Dr. Watsky, Dr. Deutsch, Dr. Waddington, all the people. I mean, it's just one of the best academic turf grass schools and academics in the country. So, getting a degree from there is something to be proud of.
Thank you, Paul, Ben, and Dave for taking the time to present to us tonight. It really meant a lot, and a lot of great information for all of us. With that being said, if there's no further questions, I will stop the recording.